The Deuteranomaly. What is that, you might say? Does it sound familiar? Have you heard it before? Well, the Deuteranomaly is a deficiency in the vision system most likely found in most males in America. So, the vision system. It's one of the five senses. Hearing, smelling, taste, and touch are the other four, but sight is one of the most important ones. It contains three main parts, those being the eyes, the nerves, and your brain. So, your eyes. Your eyes are a very, very complex system of things that make it together using the three main parts into making a clear picture for you to see. So, the eyes are the main organ in the vision system, comprised of multiple parts that all work well together. Those parts being the cornea, which transmits light, and then from the cornea it goes to the iris, which controls the light, the lens focusing the light rays, making sure it hits the retina, the vitreous humor holding the retina flat, maintaining that shape of the eye, and then the retina housing the rods and cones that connect to the nerve fibers, your brains, and your nerves. So the vision pathway from the eye goes such like this. It moves from the back of the eye through the optic disc, through optic nerves. They cross at the optic chasm, goes through the brain, through the middle of the brain, and it attaches at the occipital lobe of your brain. All information sent from these nerves are comprehended at the primary visual cortex of your occipital lobe. This is known as cranial nerve number 2. So, what is the Dewar anomaly? Well, as stated before, it is the most common type of the red and green color blindness. It's a deficiency found in the X chromosomes. It blends colors together, making them closer together. So, what I've been told in this picture, because I myself have the Dewar anomaly, is I don't really see a big difference in these pictures. But from what I've been told and from what I've researched, these tomatoes on this side appeared a bit more greener than the rest. While sometimes over here, they might appear a bit brighter. So, how is the Dewar anomaly obtained? Well, all color blindness is a genetic trait. It's obtained from the parent's X chromosomes. This means that if all X chromosomes have to carry the gene to have the deficiency. So, if in a female you have two X chromosomes, then both of those X chromosomes have to carry the gene, otherwise color blindness is not present. So, if one X chromosome does not have it, then color blindness isn't there. But if both of them have it, then it is there. So this makes males a lot more likely only having one chromosome to have the color blindness deficiency. So if the mother is a carrier giving the male child the X chromosome, then that means that all males in the family will have this genetic disease. This can be seen in my family, as my mother is a carrier having 3 boys and 1 girl. All 3 boys having this genetic disease, while the girl, on the other hand, does not. This means that my father is not a carrier, but my mother is. So, as my youngest sister, she has the two X chromosomes. One of them not having the trait, meaning that she herself does not have the color blindness, while the other 3 boys in the family do. So, what does this affect? Well, for me personally, it's limited a lot of job opportunities in the field. This includes police work, being a pilot in the military, as well as being an electrician. So, in police work and in their line of duty, police are known to have certain characteristics that they themselves find, and if you're not able to describe them or give them the exact color, the suspect might get lost or something else might happen. Being a pilot in the aviation field, there are so many different signals that include the red and green color blindness that are necessary to do their work. Electrician is a bit of the same, having to connect a green wire to a green wire, but if you connect a green wire to a red wire, you might have a catastrophic failure. And it just alters the colors of the world, making them appear closer together. So, how can this be diagnosed? I personally was found in an eye exam where my doctor gave me a book of these color blindness tests with different red and green circles inside a bigger circle that usually make up a number or a shape. So, if the number is identifiable, then color blindness is not present, showing that you can see through the colors and you can see the pattern made. But if the number is unidentifiable, then color blindness is present. So, what are some long term effects? Well, through my family, we've had a lot of mild confusion with colors and misjudgment of colors, arguing about what color the building is because we see a different color than they do. Personally, I've had something called tired eyes. This is usually found in looking at a very specific color of like a sheet of paper and having my eyes then replace that color with most of the stuff around me, making me see a very different color than what other people see. So, what's some treatment for it? Well, there is no cure currently for this disease. So, right now, some special glasses and contact lenses might be able to help, but it's not found very often to be mind breaking or a complete treatment. Some future treatments that are in research right now is some genetic replacement, being able to switch out at least a little bit of that chromosome in order to maybe not make the parent or make the mother a carrier. And then there's also one for eye surgery to replace those rods that are, sorry, replace the cones that are recepting those colors. So, some tests for that. What color do you see? Do you see anything there? How about this one? Any colors there? So, what numbers did you see? Did you see any shapes? Did you see anything? If you didn't, are you yourself colorblind? What a great way to find out. Here are some sources that I used. Most of these are articles and government documents specifying exactly what each of these or what the Deuteranomaly is. Thank you so much. I hope that you learned a lot, enjoyed the presentation, and have a wonderful rest of your day.